In this video, I'm going to cover graphing and evaluating an absolute value function and then finalizing it with converting that absolute function into a piecewise definition. So our function here is labeled h of x, and that's what we're going to be using for this problem. Starting with finding the vertex. The vertex is always the opposite of the value that's inside the bars with the x. You can also think of it as the value that would make what's inside the bars the 0. So right now I have a -6 in my bars. So the opposite of -6 is +6. That's the x value of my vertex. The y value of my vertex is going to be this number in the back, and you don't have to change the value of it. It's just going to be a +2. So x value is 6, y value is +2. Our delta y over delta x is our two different slopes. So we have two different slopes in this line. Those come in right here. They're what is just touching our absolute value bars. That's right in front of it. This has a -1/2. So obviously one of them is going to be -1/2. But when we think about an absolute value graph, absolute value graphs are V-shaped. So if one side has a -1/2 slope, the other side's going to have a +1/2 slope. So we can also write down 1/2. You could also write this as plus or minus 1/2 as well. And just as a note here, because the slope that is listed in our equation is negative, this is called our A value. Because it's negative, this graph opens downward. So I'm just going to write that down. Our V shape should be opening downward. The right side of our graph will have a negative slope. Let's go ahead and graph our equation. I'm going to start at the vertex, which is at 6, 2. So from the center of my graph, I'm going to start right here, and I'm going to go over to the right 6 and then up 2. So I'll go over 1, 2, 3, 4, 5, 6, up 1, 2, and I'll draw my point. From there, I'm going to use the slope. The slope that I have here, my change in y and over change in x, is -1/2, meaning I'm going to go down 1 square and then to the right 2. And again, down 1 square to the right 2. I ran out of room. Keep in mind, it's absolute value. We know it's absolute value because of these bars here. Absolute value graphs make V shapes. So if we go back to our vertex and go down 1 to the left 2, we'll create a mirror image that will come up as a V shape. So keep going down 1 to the left 2 until you run out of room. Now, I just want to note before I draw in my lines and arrows, the left side here has a positive slope. So remember how we wrote two different slopes? Positive slope on your left side because it's going upward, and then negative slope on your right side since it's going downward. And the reason this opens down, again, is because the A value in your equation is negative. So this is negative. That's why it opens downward, not upward. We're going to write in the equation for our axis of symmetry. The axis of symmetry exists where the mirror image happens. So the mirror image happens right here. On either side of this dashed line I'm drawing in, it's equal, right? It's a mirror image. So things on either side of it match up. Like this point would be a mirror image of that point. And then this mirror would be a mirror image of that point. And then there's more points over here that would be mirror images of the left side. So our axis of symmetry equation is going to be x equals 6. Now, how did I get that? My line here crosses my x-axis at 6. So all of the x values on that line are 6, meaning our axis of symmetry cuts straight through the x-axis at 6. 6 happens to be the x value from our vertex. So every time you're getting your equation for your axis of symmetry, all it is x equals the x value of your vertex. So I'm going to say x equals 6. And that's that pink line that I added in the middle there. I'm going to go ahead and make these dots blue again so you can keep track of what I'm doing. We are going to do our x-intercepts. X-intercepts are where the line crosses your x-axis. So I'll do these in green. My x-axis is the horizontal line that goes left and right here. There are two spots where it intersects that horizontal line. Right here and right here. And we just have to say what those points are. So the first one here is at 2, 0. And I knew that because they're going to be on 0 for your y value, because anytime you're at your x-intercept, your y value is going to be 0. This is just 2 squares over from the center. So my first one is 2, 0. And then my second one is going to be 10 comma 0. And I'll write an or in between those two. My y-intercept is where my graph crosses my y-axis. And my y-axis is that up and down one. It's labeled y. That is this point right here. That point crosses the y-axis at 0, -1. Keep in mind, on your x-intercepts, your y value is going to be 0. And on your y-intercepts, your x value is going to be 0. Let's talk about the domain. So the domain can feel a little bit daunting or confusing. The domain is just the farthest left a graph can go and the farthest to the right a graph can go. So if we look at these arrows right here, they're really important. We have 2 arrows. Those arrows mean that these graphs go on infinitely in either direction. So if they go on infinitely, wouldn't we keep going to the left and the right forever and ever and ever? So there wouldn't be any limits to our x values, which are our left and right values. There wouldn't be any limits to those. So our domain here is going to be -infinity and positive infinity, because there's no limits to the left or there's no limits to the right of this equation, and the numbers go on forever. If you would like, you can also write a double R, and that stands for all real numbers. So all real numbers are possible solutions for our x values. For our range, pretty much the same thing as domain, except you're looking at up and down values, and those are going to be your y values instead of your left and right values from your domain, which are your x values. So I'll just write a little note here. These are your x values, and these go left to right, and these are your y values. They go up and down, just so you are tracking. So up and down, there is a limit. So these arrows, again, they go on infinitely, but they only go on infinitely down. There is actually a maximum in this graph. There is a maximum right here. That's at my vertex. So your maximum, or sometimes it'll be your minimum if your graph is facing the other way, your maximum is going to be the y value of your vertex. So right here, this line would be y equals 2. And we can go all the way up to 2, but we can't go anywhere above that line. So our maximum here is going to be 2, and our minimum is going to be -infinity because it goes on forever. And to write that in your interval notation, you'll start with a -infinity, and then we're going to put a 2 on the other end. I use a bracket around my 2 because the dot at the top is filled in. If that dot were an open circle, you would be using a parenthesis instead of a bracket. Another way to write the range is you can say your y values are all less than or equal to +2. Because think about it. +2 is right here. All of our values are down below it. So all of our y values are less than or equal to +2. Now, we are going to write a piecewise definition of this function. Piecewise definition just means we're going to break it in half at the axis of symmetry, and we're going to write a equation for the left side and the right side, okay? So I'm going to start with the right side here. The right side here has a negative slope, okay? And I know it's negative because it's going down. And if I look at my slope, it looks like I went down 1 to the right 2. That also happens to be the slope from my original absolute value equation. Now, I can use the vertex for my piecewise definition. And I will always use the vertex because it's the point that both my lines share, and I don't have to do a lot of thinking. My vertex is a very easy point. This point right here, our vertex was at 6, 2. So 6, 2 is my point, and my slope on this side is -1/2. So I'm going to go ahead and write the definition for that line. And keep in mind, this is a line segment, so it's only part of a line, and it is a straight line. And straight lines are linear, so when we have straight lines, we're going to be using parentheses in it instead of absolute value bars. So just for that right side, that side I have highlighted in yellow, our equation is going to be f of x equals -1/2 times x minus 6. And I'm doing -6 because in my equation, I want to do the opposite of what my x value is. So my x value is 6. The opposite of 6 is -6. Then I'm going to add 2 on the end. You may notice it is almost identical to this right here. It's almost identical. And the only difference is that we're using parentheses. Okay. So we're using parentheses there instead of absolute value bars because we're talking about a straight line. Now, the equation for the line I just wrote, that line goes on forever in this direction. But our line that we're talking about actually stops right at that pink symmetrical point, right at our axis of symmetry. So that line only exists when our x values are greater than or equal to +6. So this is +6 right now, and greater than or equal to would be in that direction. That line only exists from here over, from 6 over. So it's when my x values are greater than or equal to +6. And that's going to be your axis of symmetry and your vertex, just in case you need that information. All right, now we have to do the left side. And on the left side, we're going to change it up just slightly. There is one major difference on the left side than our right side. You can probably see it. The slope is positive on our left side. That's what I mentioned earlier. We have a positive 1/2 slope. So our delta y over delta x is positive 1/2. We still share this point. So our vertex here is still 6, 2. So we can still use that point in our equation. The only difference we have here is our slope is positive. So it should be a really easy equation to make. Since instead of having a negative 1/2 slope, we have a positive 1/2 slope, all we have to do is write 1/2, same exact numbers, so x minus 6 plus 2, but then we have to say when this equation exists. So we already have an equation for when x equals 6 and when everything is bigger than 6. But we don't have an equation for when everything is less than 6, right? So this is clearly going to be when my x values are less than 6. That is the piecewise definition. And just so you are following, this is my green line from my graph. And then that top one is my yellow line. So the yellow line would represent the right side and the green line would represent the left side. So positive and negative slopes. All right, let's try another one. I got 3 more examples of these. All right, we can do these pretty quickly. Our vertex will be the opposite of +3, which is -3. And then our -4 will remain the same. So we have -4. Let me write that a little neater. Perfect. My 2 slopes will be positive and -4. And remember that slope is what's touching your bars there. So we're going to have a positive and -4 over 1. And I'm just going to note that this opens upward. And the reason it opens up is because this a value in our equation is positive. Let's go ahead and graph it. We're going to start at -3. So go back 3 and down 4. That right there is our vertex, -3, 4. From that point, I'm using this slope, +4. So I'm going to go up 1, 2, 3, 4, and then I'm going to go to the right one. So anytime there isn't a number, like if this isn't a fraction, this is just 4 over 1, just to clarify. So we're going to continue doing that until we run out of room. Go up 1, 2, 3, 4 over 1, up 1, 2, 3, 4 over 1. And I ran out of room. Now I'm going to go back to my vertex. Remember my vertex is this point right here, -3, -4. This should be a V-shaped graph. It's V-shaped because it's absolute value. So I'm going to make a mirror image for my vertex. I'll go up 4 to the left 1, up 4 to the left 1, up 4 to the left 1. Then I can draw in my lines and my arrows. You can see on this one, my left side has a negative slope and my right side has a positive slope. So just keep that in mind for this one. It's a little different than the last one. Let's write our equation for our axis of symmetry. I'll do that one in pink again. So our axis of symmetry is going to cut straight through the middle of our graph. And the middle of our graph hits the x-axis at -3. So our equation is going to be x equals -3. Keep in mind that is your x value from your vertex. So we'll say x equals -3. Let's find our x-intercepts. Our x-intercepts are going to be where they cross the x-axis. So my x-axis is my horizontal axis. There's one right here, and then there's the second one right here. This point here is -2, 0, so it's back 2 from the center. So -2, 0 is one of my vertexes, or my other vertex is negative 4, 0. Now we're going to find the y-intercept. The y-intercept is where your graph intersects with your y-axis, and it intersects with my vertical up and down y-axis way up there, and that is going to be at 0, positive 8. 0, positive 8. And it is 0 for x because it's your y-intercept. So keep in mind, your x will always be 0 at your y-intercept, and your y will always be 0 on your x-intercept. All right, our domain. Keep in mind we have those arrows. I didn't highlight them quite as much, but these just keep going on forever. They go on forever to the left and the right, right? So our left and right limits don't exist, right? We have negative infinity and positive infinity. They go on forever and ever and ever. There's no limit there. There's no limit at all. You could also write all real numbers. Your range, it bottoms out right here. So this is the y value of our vertex, and it bottoms out at negative 4. That's our minimum. It goes on in the upward direction forever and ever, though. So our upper value would be infinity, and our lower value would be negative 4. Keep in mind, you have to use a bracket on your negative 4 because that dot is filled in. Also, I'm putting the negative 4 first because I always want to put my smaller number on the left and my larger number on the right. If you want to do that in inequality notation, you can just say y is greater than or equal to negative 4, because this is negative 4, and numbers that are bigger, greater than negative 4, are all upward, so everything above negative 4 would be a solution. All right, now we're going to do our piecewise definition. Let's break this into two pieces. I'm going to go ahead and highlight my right side as the yellow side again. Let's go ahead and write the definition of that line. That line clearly has a positive slope. We go up 4 over 1. So it's a positive slope, and we're going to use the vertex. The vertex here is at negative 3, negative 4. Let's go ahead and make our equation. It's going to be h of x in this case. H of x equals our positive 4 is our slope. And then remember, it's a line, so we're using parentheses. You're going to say x, and then the opposite of the x value here. So the opposite of negative 3 is positive 3. So we're going to say x plus 3, and then we're just going to leave our y value the same. So the y value here is minus 4, so we're just going to leave it as minus 4. Remember, this only exists from this pink line over. So that pink line represents when x equals negative 3. So it only exists when the line is equal to or greater than negative 3, because numbers that are greater than go to the right. So this is when x is greater than or equal to negative 3. Keep in mind that negative 3 is your axis of symmetry and the x value from your vertex. All right, that is our yellow line. That's our right side there. Let's go ahead and do our left side. So I'm going to highlight my left side in blue. Clearly, this one has a negative slope. This should be pretty straightforward. Negative 4 over 1, right? So the only things that are going to change are our slope and our domain. And this is our domain back here. Our domain is our x is greater than negative 3. So our slope changes from a positive to a negative. Our vertex remains the same, so we don't have to change it at all. And then we've already done from equals negative 3 to greater than negative 3. So all we have left to do is the less than negative 3. So this is when x is less than negative 3. And that is our blue equation, which is our left side. All right, we got 2 more examples we're going to work through. Let's keep going. Our vertex will be the opposite of negative 6, so positive 6, and then you keep the positive 3 the same, so it will be 3. And then my 2 delta y over delta x's will come from right here. It will be positive and negative 1/3. Because this a value in our equation, that's our slope written in our equation, because that is negative, we are going to open downward because we have a negative slope in our equation. Let's go ahead and graph it. We'll start at positive 6. 1, 2, 3, 4, 5, 6. Positive 3. 1, 2, 3. We'll draw our point. From there, we'll go down 1 to the right 3. So keep in mind, this slope will be the right side of your graph. I can only fit 1 point when I'm going down 1 to the right 3. So to make this a mirror image, I'll have to go down 1 to the left 3. because I want a V shape because this is absolute value. You'll keep filling that in until you run out of space. There we go. The left side here has a positive slope, right side has a negative slope. Let's go ahead and write in our axis of symmetry. I'm going to make my line just a tiny bit thicker so it's a little easier to see. My axis of symmetry is going to cut straight through the center. So my axis of symmetry will cut here. And that hits my x-axis at positive 6. So my axis of symmetry will be x equals positive 6. So we'll say x equals 6 as my axis of symmetry. Now, I have to find my two x-intercepts. So this is kind of an interesting one. My x-intercept over here, off the graph. So I kind of have to do some math, do some thinking, and try to come up with what that number is going to be. Allow me to explain. So my first one will clearly be here at negative 1, 2, 3. So my first one's at negative 3, 0. My axis of symmetry is right here. I am 1, 2, 3, 4, 5, 6, 7, 8, 9 squares away from my axis of symmetry. So my other x-intercept will be 9 squares away as well. So it'll be 1, 2, 3, 4, and then I have 5 more. 5, 6, 7, 8, 9. So 5 beyond 10 would be 15. My other one would be 15, 0. If you aren't able to do that just by counting, like if you don't understand the symmetric point and the distance away, just go ahead and plug in 0 for y, or in this case for f of x, and you should be able to solve that. All right, our y-intercept is again where it crosses that up and down axis. So that's right here at positive 1. So it's going to be 0, positive 1. 0, positive 1. Our domain, this thing goes on forever, right? So our domain to the left and right, our limits to the left and right go on forever. So it'll be negative infinity, positive infinity. Feel free to write that double R if you prefer. And then our range, we cap out up here. We cap out up here at the y value from our vertex. This is positive 3 is where we cap out. It's from there and below. So from positive 3 and below. So our maximum value is positive 3. Our minimum value, it goes on forever, right? So our minimum value is negative infinity. Positive 3 is our maximum, and we'll use a bracket because that circle is filled in. You could also write y is less than or equal to positive 3 if you prefer that. Let's do our piecewise definition. So we'll do our yellow side here. Sorry. Our yellow side is our right side. Let's go ahead and write it out. So our slope here is negative 1 over 3. It happens to match up here. Our vertex right here is at 6, 3. So we should be able to make an equation once we have the slope and the vertex. Our slope is going to be negative 1/3. You multiply it times x. The opposite of 6 is negative 6. And then you leave your 3 alone. So it'll be a plus 3. This is from our axis of symmetry over. And remember, our axis of symmetry is at 6. So it's values that where x is 6 or bigger. So this is when x is greater than or equal to 6. On the left side, I'll make the left side blue. This is going to be when our x values are less than 6. Just to clarify, obviously this has a positive slope, so it's going to be a positive 1/3 slope. We're using the same point, so the only thing that changes is we have 1/3, x minus 6 stays the same, the plus 3 stays the same, and then our x values are just less than 6. So remember, 6 is our axis of symmetry. It's also our vertex. It is the point we use in the domain for our piecewise definition. And I'll go ahead and highlight these. Again, this is my blue one. That's my left side. And this is my yellow one. It's my right side. Okay, one more problem. Let's do it. This problem, the vertex is going to be the opposite of positive 2, which is negative 2, and then we're going to keep the negative 3 the same. Our 2 delta y over delta x's are going to come from here. It's not a fraction, so we just put it over 1. It's going to be positive and negative 2 over 1. Let's graph it. We're going to be at negative 2, negative 3. From there, I'm using the positive slope for the right side of my graph, so I'm going up 2 over 1. Up 2 over 1. Keep going until you run out of space. On the left side, I'm going to go back to my vertex and make a mirror image by going up 2 to the left 1. Perfect. I'm going to draw in my lines and my arrows. The equation for the axis of symmetry is going to be where it cuts through our vertex, and that will hit my x-axis at negative 2. Negative 2 is also the x value of my vertex. So it'll be at x equals negative 2. Let's do our x-intercepts. Now, I'm going to highlight where I think they are. Those are going to be fractions, right? So I cannot exactly see my x-intercepts. I wanted to do this on the last problem just so you have an example of solving to find your x-intercepts. So it's a little bit tight in here. I'm going to fit it right here. I'm going to say my y, or in this case, my h of x, I'm going to make it 0 to solve for this x to figure out what my two x-intercepts are. They are going to be fractions because they don't land on our crosshairs. They're going to be fractions here. So I will say 0 equals 2 times the absolute value of x plus 2 minus 3. To solve this, I want to get my absolute values bars by themselves. So I'll add 3 to both sides, and I'll get 3 equals 2 times the absolute value of x plus 2. After that, I can divide both sides by 2, and I'll get 3 halves equals the absolute value of x plus 2. From there, I can break it into a positive solution and a negative solution. I'll have 3 halves equals x plus 2, and then negative 3 halves equals x plus 2. If I subtract 2 on this side, I can't really subtract 2 from negative 3 halves, but I can subtract 4 over 2. 4 over 2, if you think about it, 4 divided by 2 would just be 2. I need a common denominator, so it's going to be 4. This side is going to give me negative 1 half equals x. So my first point will be this one, which is at negative 1 half comma 0. And then my second point, if I subtract 2 on both sides, I have to change this one to negative 4 halves. Let me fix that really quick. This should be 2, so negative 4 halves. This will give me negative 7 halves equals x. So negative 7 halves comma 0. Those are my 2 points. My pen's dragging a little bit. Let me fix that. Sorry. Negative 7 halves comma 0, or negative 1 half comma 0. Now your y-intercept's really clear. So that's much, much easier. You don't have to do a whole solution to work it out. Your y-intercept will be right here at 1. So your y-intercept will be at 0, positive 1. Your domain, these things go on forever and ever, right? So your domain is going to be positive and negative infinity because left and right, there's no limits. And then your range, it bottoms out here at negative 3, right? And it's from negative 3 and up. So I'm erasing everything but the line I'm trying to erase. Let me try to fix that. Sorry. Having trouble on my last one today. There we go. So it was here at negative 2, negative 3. Let me draw those lines back in. Excuse me, everybody. And it's going to be from negative 3 and above. Okay, so from negative 3 and above, meaning that negative 3 is my minimum. It's included, so I use a bracket, and then infinity is my maximum because it goes on forever. You could also say your y values are greater than or equal to negative 3. All right, last step today. We're going to write the piecewise definition. So this side here has a positive slope. Our right side has a positive slope. And the positive slope is 2 over 1. Our vertex here was -2, -3. So let's write this equation. It's going to be y equals, or in this case, f of x equals 2 times x. The opposite of -2 is +2. And then our -3 stays negative. So it does match this, just so everyone knows, just the parentheses are, the bars become parentheses rather. And this exists from this point right here, which is x equal -2, and to the right, and the numbers to the right are greater. So it will be when x is greater than or equal to -2. The other side is our negative slope. So we will have -2 over 1 with the same point. The only thing that changes is our 2 becomes negative. That exists when our x values are less than -2, when x is less than -2. So let's color code these, and that will be it. That covers evaluating our piecewise definitions, our absolute value graphing, the whole thing. Thank you.